You're listening to Capturing Christianity, a ministry aimed at exposing the intellectual side of Christian belief.
No need for a long introduction for this one. Here's Cameron and Luke with their 90-minute Q&A on the fine-tuning argument.
Hello and welcome to Capturing Christianity. My name is Cameron Bertuzzi. I'm exposing you to the intellectual side of Christian belief. Tonight we're talking about the fine-tuning argument for God's existence. I've got Dr. Luke Barnes here with me. Let me pull up my screen here. Dr. Luke Barnes, he's a cosmologist. He works you're in Sydney, is that correct?
I'm Australia. Indeed in Sydney, Australia.
Well, we're not going to take a whole lot of time. We want to get into, this is a Q&A. We're basically devoting most of this live stream to Q&A from you guys. So if you have a question for Dr. Barnes about the fine-tuning argument, write it in the live chat right now. We've already had one guy send in a super chat, so we'll get to that in a second. But what we're going to do at the outset of this video is Dr. Barnes. You mind if I call you Luke? You've been on the show many times.
Please do.
All right, Luke. So what we're going to do at the outset is we have some slides prepared, and basically what Luke is going to do is he's going to give us an overview of his version of the fine-tuning argument, what it is, what it says. He's got some slides prepared, and so we're going to run through that first. So if you have a question for him, feel free to put it in the live chat. I'm still going to be looking through there. But in the meantime, we are going to do this. We're going to go through and just give a kind of overview of the argument. If you want to learn more about Luke, then check the description of the video. I've linked to his blog, and you can find out more about him and his background. But we're going to kind of skip that for this so we can devote most of it to the content. So here we go. Let's pull up the slides, and we'll get started. Just, go ahead and take it away.
Excellent. So the book on the left is the book that I wrote with Geraint Lewis on the fine-tuning the universe for life, A Fortunate Universe. Just shameless promotion. We've got a new book out about the evidence for the Big Bang Theory. And if you want to overthrow that theory, what you have to do, called the Cosmic Revolutionary's Handbook. You can ask me about that if you feel like it. So there's a formulation of the argument that I like that actually came out of next slide, out of a blog post that I did for the Capturing Christianity blog. So
that's right.
Yep. That's not come up on my screen? Is that?
Oh, here we go.
Slide, yeah. Okay.
Sorry about that. I was looking at the comments. Someone said that my audio is a bit low. So let me know, guys, if it's just low for him or if it's low for everybody. So let me know in the live chat. All right, so let's get to the next slide. Here we go.
So the blog post on the left there, what you can't do with a multiverse, and that sort of turned into the paper, which is on the right, which is accepted for publication but not yet actually published. So if you want a copy of that, just send me an email or something, but hopefully that'll be out soon. Next slide. So the idea here is to start off with sort of the context into which, don't jump straight into fine-tuning. Let's just think about naturalism. Just think about the idea that the universe is all that there is, that physical stuff is the only stuff. So that's a sort of basic definition of naturalism. When you're thinking through any sort of idea, whether you're a scientist or not, you want to ask, okay, if that idea was true, what would I expect to see in the world around me? So this is what you do especially as a physicist. If Einstein's idea about gravity were correct, what would I expect to see when I look at the center of our galaxy, when I look close to the sun, when I look at the way Mercury orbits, all these sorts of things? What would I expect to see? And so naturalism shouldn't be immune from that. And so we should be asking about naturalism. Of all the possible ways that a physical universe could have been, is our universe what we would expect on naturalism? So this is kind of the big question. However, the big question is very, very big. So all the possible ways a physical universe could have been, if we think we can specify a physical universe, I'm a theoretical physicist, so, I just write down the equations that describe a universe. That's kind of what I do for a living anyway. But all the possible ways would kind of be all the possible mathematical equations that could describe a universe, including maths we haven't even discovered yet. So that's a bit of a problem. So there's two options here. Either we kind of abandon this question entirely, and I think that's a bad idea if you're a naturalist, because if we can't even get any sort of grasp on this question, then we can't make a case for naturalism, yet alone a case against it. And a lot of the standard arguments, like the argument from evil, I think this question's relevant for that as well. So I think it's a bad idea for us to abandon this question. So what we need to do is to try to get at this question in some way. We can't completely answer it, but we can have a go at it. So the idea is, well, we have the fundamental laws that describe our universe, and let's have a closer look at those. Okay, if we were trying to answer the big question, we'd have to consider all possible, equations at least. But we've got sort of a smaller. We can do it something smaller in there. If you look at the equation, there are these constants in there that we have to specify. And what if instead of trying to change the form of the equation, which is too hard and too big, what if we just change the constants and used that as a way of generating a large set of other possible ways the universe could have been, and we just investigate that? So that leads us to, next slide, the little question. Of all the possible ways that the fundamental constants of the standard models could have been, is our universe what we would expect on naturalism? So sort of pictorially, next slide, here's what's going on. We've got the thing we want to investigate, all possible naturalistic universes, but that's a great big set that we can't really get a handle on. We can't explore that territory. Next slide. We're in there somewhere, presumably, or at least, the natural part of our world is in there somewhere, not assuming naturalism is true. But here's what we can do. If we go to the next slide, we can take a subset of our laws, plus we just vary the constants, and we explore that terrain and see what that set of possibilities looks like. And so the reason why we go for the little question, in short, it's like the big question, but we can actually answer it. So next slide, here are some reasons why this is actually a reasonable approach. The little question has been addressed by physicists for the last 40 years, but not for the purposes of testing naturalism or promoting theism. It's nothing like that. We're just addressing a model. We're looking at the constants of nature. Secondly, we can calculate what the universe would be like with these different constants and initial conditions. We have the equations. We can do theoretical physics. And so we can actually, with some degree of certainty, know what things would be like with different constants. Whereas if you go to completely different equations, things, it's not a given that we know what would happen. It's systematic. We aren't just checking every possibility we can think of. We have a well-defined set of constants, well-defined set of ranges. We can go and look through all of them. It reflects the best rather than just infinitely postponing them until physics is finished. I guess, actually, the way I've put it, you'd have to also finish mathematics as well if you're going to answer the big question in that way. It varies the only feasible degree of freedom in the fundamental equations as we have them. So if you look at the equations, you can either mess with the form of the equation, or you can mess with something in the equation, and the constants are sort of the only feasible way of doing this. The probabilities we need, I can explain this in more detail if people have questions, but the probabilities we need are also needed to test those theories in the first place. So we want to say something about what is likely and what is unlikely and map the terrain. We have to be able to do that within physics as it stands now, just to do ordinary physics. So, for example, if I want to know, given all the data I have, what's the probability that the electron mass has this value or this range of values? That's a distribution. In order to answer a question like that, I need a certain set of probabilities over these constants, and those are enough for what we're trying to do in this case with the fine-tuning argument to answer the little question. And if anything, it's biased in favor of finding universes like ours. We have the whole of that naturalistic possible naturalistic universes. We went to a subset, but it's a subset that we know contains our universe. So if anything, we're biased in favor of finding universes that are like ours, if anything. So why the little question? Next slide. In short, it looks like the big question. It hopefully is our best chance at a question that reflects the big question, but we can actually answer it. We can actually go after it. And so we've explained this in the book. here's a little slice of that parameter space. If we go to the next slide, just very briefly. So I've done a video with Cameron before about fine tuning.
The evidence for fine tuning.
Yeah. So very quickly, here's an example I like. The basic bits that you're made out of are the up quark, the down quark, and the electron. Right. So those are the three Lego pieces that make up you. A basic property of those Lego pieces is how heavy are they? Right. What's their mass? And so we could map out, in this case, it's a three-dimensional little piece of that parameter space with, if you pick a point in this cube, you've picked the up quark, down quark, and electron masses. So you are here, and it's a logarithmic scale, and we can define the top as being the Planck mass, where our theories sort of run out. So there's a limit there. And so what we can now do is to say, all right, what would things be like in other bits of this parameter space? We have the equations. We can change the numbers. We can go and ask this question. And so next slide. So, for example, if you want, we cut out that sort of back little slice there, because if you're in that part of the slice, then the basic bits of the universe basically don't stick together. So you can stick up and down quarks together to make one type of slightly bigger particle, a hadron, and that's it. No periodic table, no complexity, no information carrying anything in the universe. Stuff will not stick to other stuff. And next slide, as we go on and think about other criteria, we want them. We want basically to have a periodic table, and we want stars. And so you end up in this little slice, and the next one you actually have to be an even smaller slice than that. Next slide. You have to be in this little tiny space in order to have a universe in which you have stable forms of energy in the universe, like stars, and stable things like the periodic table, anything that can build complexity. And so next slide. So Geraint an atheist, by the way, so all the science of this is still being actively looked at, but it's not something where, it was just made up by theists. So the first 6 chapters of this book are just an atheist and a Christian both talking about what happens if you change the laws of nature. And so the short answer is, if we go to the next slide, the answer to the little question, of all the possible ways that the fundamental constants of the standard models could have been, is our universe what we would expect on naturalism? The answer is a pretty firm no. That's the answer, fine tuning. And so the best handle we have on the big question of whether naturalism generates the right expectations for the universe we see, the answer is no. Very quickly, just to finish, a common objection. This approach, big question, casts on some common objections. So if we go to the next one, the multiverse is the objection that, these constants, maybe they vary in other parts of the universe. Maybe if I go far enough in that direction, I'll find another bit of the universe with different values of the electron mass and the up quark mass and all of that sort of stuff. So maybe we just sort of won the cosmic lottery. Within this context, keeping in mind that we're trying to get the best handle we can on the big question, can I use multiverse theories to get to formulate the little question better? It's not going to get us to the big question, but can I get a little question 2.0, a better little question which explores a bit more of the possibilities? And the answer to that is, at this point in time, no. I mean, I've written papers on. No, it's fine. The best theories of the multiverse we have are still kind of toy models. So I've written papers on the multiverse. Some collaborators and I have spent hundreds of thousands of computing hours trying to simulate what would happen in other parts of the multiverse. So, this is something we can investigate them, but can I actually formulate? Is there a landscape of multiverse models where I can get a handle on the whole landscape in the way I can with the constants? The answer is just no. So in light of that, that tells us what this objection really is. If we go to the next slide, remember, here's our map of what we're trying to do here. If you add the multiverse in, if you go to the next slide, what we're trying to do is expand out the part of the whole that we can investigate. We won't just look at our laws plus varied constants. We'll look at new laws of nature that hopefully make a multiverse, and then look at that landscape. And so that tells us what this objection really is. It wants a rematch. Okay, the real arena is the blue arena there. But we can't get a handle on the whole terrain there. And so we look at the feasible arena of the yellow one, our laws plus varied constants, and that went really badly for naturalism. So maybe we can expand the arena out and hopefully things go a bit better in the red arena. But the answer to that is we just don't know what happens in the whole red arena. We have examples like points out in the red bit that are examples of multiverses, but no idea about what the terrain is. Finally, last slide, if we go to the next one, there's a really great test of any objection to the fine-tuning argument. I've called it the awesome theological argument. That's my name, but it's not my approach. It goes back at least to John Leslie's wonderful book, Universes. So the idea is this: suppose tomorrow in every language that currently, that can be written down on Earth, in various parts of the sky, the first 14 verses of the Gospel of John turn up, right? So it turns up in English and in Greek and in every language, and that turns up. That seems like it would be pretty good, written in the stars. That seems like it would be pretty good evidence for God. And so the thing to do with your objection to the fine-tuning argument is try it out against that scenario and see what happens. So it seems like in that case we would have an awesome theological argument, right? Now, we don't know all the possible naturalistic universes, but we're pretty sure of all the universes in which there are stars in the sky, the set in which it spells out the first 14 verses of John in every language is a very small subset, and so that's a problem for naturalism. So this argument from the first 14 verses of John has the same form as the fine-tuning argument, and so we can just throw your objection at that argument and see how it looks, and then try and throw it at fine-tuning. So that's my intro.
The name of that awesome theological argument, how is that related? Because it sounds like you're just saying if you can't, if your theory of the multiverse can't account for this design inference, then your multiverse theory is a really bad one. Where's the connection between that and the awesome theological argument? Where did you get that name from?
Oh, yeah, I made that name up.
Okay.
But it's basically there's some really interesting papers by John Hawthorne and his last name's Isaacs. People can look it up. Fine-tuning, and misapprehensions about the fine-tuning argument. They push this one quite nicely. I just wanted a nice name for it. But so the idea is not that this is an answer to the multiverse objection, but just that you've got to the fine-tuning argument. Any objection you've got, throw it at the awesome theological argument and just see what happens. Just to get some instinct about what's going on here. In short, if that actually happened, there'd better not be any good objections to the awesome theological argument, right? If those 14 verses really did turn up in every language, that would be good evidence. And so there'd better not be any objections to it.
Okay, well, let's go to questions. I mean, like we said, what we wanted to do at the outset was to just give a kind of overview of what Luke's view on the fine-tuning argument is, and I think it's a very interesting take, and I don't know that you're going to see that from really anyone else. I mean, if you think about William Lane Craig's version of the fine-tuning argument, it doesn't look anything like that. And same with Robin Collins. Robin Collins uses a probability approach. I mean, ultimately, I think you're going to get down, if once we write it out, it's going to be kind of the same thing. But I wanted to take some time at the beginning of this and just sort of spell out what your view is, and that way we can, as we're addressing the questions, as you're answering them, we can just keep that in mind as some context here. Well, let's get to the first question. The first question, this is a super chat from Jonathan Becker. Thanks for your super chat, Jonathan. He says, can you discuss observer selection effects? Do they undermine our ability to make likelihood arguments? As Edward Sobel argues.
So actually, I think Sober's slightly changed his mind about this. So here's the short story. The thought is, I think the way Sober puts it is we have certain blind spots. There are things that could be true, but I can't believe them about myself. So his example here for the fine-tuning argument is, it couldn't possibly be the case that I live in a universe which doesn't permit my existence. And so if there were any, this is an observer selection effect, any universe which is observed is a universe which permits the existence of observers. So observer selection effects are very common in astronomy and in all the sciences, really. You have a population you want to investigate, but you can't get all of that population, and so you sample a subset of that population, and then you have to worry about, does the sample reflect the whole population? So the elections are the classic example. I want to know how everyone's going to vote, but I can't just ask everyone, 2 weeks before the election. And so I'll go and sample 1,000 people at my local mall or something. You have to worry about whether that sample reflects the overall population.
Whether it's representative.
Yeah. And so the thought is, when you have an observer selection effect in terms of your existence, of course, my existence kind of selects a sample of out of the possible universes, which permits my existence. If that's a trivial, that seems to be trivial. And so what's the point here? I think the best answer to this is just, and I think Sober actually has changed his mind on this. If you ask the question, why is there a life-permitting universe at all, then it becomes clear that actually the selection effect doesn't answer that. Given that there is a life-permitting universe, why do I observe that I'm in that life-permitting universe? That's a selection effect. But there's a the fact. So here's an example from the book. There are objects in the very distant universe called quasars, which are extremely bright. And if they weren't very bright, then we wouldn't see them. But if you're asking the question, why are there quasars at all? The answer is not, because why do I observe quasars at all? The answer is not because, sorry, hang on. Got to get this right. If you're asking the question, why are quasars bright? The answer is not because otherwise I wouldn't see them. Okay, so if you're asking the question, why is there a life-being universe at all, the answer can't be something like, because otherwise I wouldn't be here. Like that seems to get the explanation wrong.
Well, it doesn't answer the right question.
Yeah. It does answer our question, but not the big question.
All right, so here's a question from Mind Onion. He says, as an experimental physics doctoral student myself, my question is, what experiment could be conducted that could show that a variable is not fine-tuned?
Excellent. Enjoy your doctoral studies. So remember the context of the argument. We are trying to get a handle on other ways the universe could have been, because that's what we have to do in order to ask a question like, is naturalism generating the right expectations? And so you do this when you test any physical theory. You have to worry about other ways the universe could have been. And so it's not an experiment. The way that you would show that a variable is not fine-tuned is using theoretical physics. Okay? It has actually been the case. So I wrote a paper in 2015 about what's called the diproton disaster. So there had been some previous arguments saying that if you had a universe in which a proton could stick to a proton, okay, in our universe that doesn't happen. They would just fall apart. Quantum mechanically, there's too much energy in in that system for them to stay stuck together, and so there's enough energy for them to fall apart. So they do. If you change the laws of nature a little bit, you can stick them together. There was an argument actually going back to Freeman Dyson in the 1970s, which said if we had a universe in which that was possible, in which that was the case, in which protons stuck together, then stars would be explosive and they would all just burn through all all their fuel in a couple of seconds, and so you wouldn't have that would be a pretty dangerous universe. The way that my paper actually shows that that's not the case, okay? And the way you do that is theoretically actually asking, what would happen in a universe in which the diproton was bound, in which you can stick two protons together? And the answer is that basically stars won't get into the situation in which they explode. You just have a slightly larger, puffier, less dense, less hot stars, and they will still burn appropriately slowly. So remembering the context of here's all the possibilities, here's the possibilities we can actually get a handle of, and it looks like life-emitting universe are extremely small subset of the sort of yellow circle, the circle we can get a handle on. The way we could be wrong about that is that there's other parts of the space there that we thought couldn't sustain life, but actually they can. So that has happened a couple of times, but in other times, we thought a part of parameter space was okay, and it turned out not to be okay. So it does go both ways.
Okay, so I have another question here about God, and I just lost it. Well, here I think I got it here. All right, from Woe Beats. He says, how can we calculate God as the possibility, though? So the equivalent question to ask is, so the big question for theism would be, of all the, if we're just thinking about the physical universe, of all the possible physical universes that could have existed on theism, is ours what we would expect? And if we're in the context of the fine-tuning argument, we have to keep the rules the same. This is the Bayesian, you've got to keep the evidence the same. We would have to do the equivalent of the little question for theism, which would be of all the ways the constants of the standard models could be, is our universe what we would expect on theism? And so that's just a question we have to ask. And the idea of, I think it'd be worth to talk about like some of the reasons, some of the arguments that you've given in favor of positive answer to that.
Yeah, so actually Richard Swinburne's particularly good on this. His book, The Existence of God, goes in this in great detail. The short story is, if there's a God who does things for certain reasons, then the approach I actually take in the paper is just, okay, what could a reason for the universe be? No, we don't have to know the reason for the universe. It's not. We're not assuming there's just one. We're not assuming where's the reason. But a God who is personal and moral, which is the idea of God that at least Christians have. So there would be a universe which achieves certain moral things, and in particular might have moral agents in it who are capable of performing morally significant actions. If that's a possible reason for the universe, then that completely changes the way that we look at the probabilities of the sort of the set of universes that we have. Most of those universes, nothing moral will good or bad. It'll just be you'll just have a universe which protons occasionally bump into each other, and that's all that ever happens. There's no moral decision making that ever happens or ever could happen. And so anyway, so the point is we're not really calculating the probability of God in any sort of strict sense, but on the sort of the things that everyone who believes in God has sort of believed about God since before the fine-tuning argument, it seems that it's more likely, or at least as likely, or at least some, not one in a squazillion unlikely, that God would make a universe which permitted life and moral agents. Again,
squazillion.
Squazillion, that's a technical term. Again, take this objection and throw it at the awesome theological argument, right? What's the probability that God would make a universe in which the stars lined up to spell out the first 14 verses of John? Now, we might not be able to get a precise handle on that, but there's no way that question ruins the awesome theological argument, right? It's just, pick any reasonable number. The argument's still going to work fine. Uncertainties like that certainly shouldn't derail that kind of the awesome theological argument. And so it's entirely, reasonable that they won't derail the fine-tuning argument either.
All right, so here's a really good question from Jonathan Becker. Another question from him. He says, seems like there's no valid probability measure for the big question, while there is for the little question. Some say this makes the little question too convenient. What are your thoughts?
Some say. The worry there is not whether it's convenient or not. I mean, we go for the biggest feasible question we can manage. Right? The big question is too big. And so, like, if you've got another approach here, which is not my little question, if you've got a bigger little question that you think can attack the big question, then I'm all ears. Go for it. Plausibly, if you're not varying the form of the equation of the fundamental equation laws of nature as we know them, then the only thing left is the constants. And so there really is a very small set of things we could go with. Too convenient. The problem here is the real worry here is whether it's biased in favor of theism over naturalism. And as I said in my reasons for the little question, if anything, it should be biased in favor of naturalism, just thinking a priori, because if we're going to start worrying about what universes can permit life and we want to investigate the whole space, okay, what's the sort of smaller feasible arena we go for? We've gone for an arena in which we know that our universe exists. We've gone for a smaller arena, a smaller question in which we know that our universe is. So we know that in that arena there is already an example of a life-permitting universe. So this is a bit like if I want to go looking for there's an example we used in the book. I think we said if you want to go looking for bears in the forest, you might have said mushrooms, whatever, bears. You want to go looking for bears in a forest, I'm in Australia. If you want to go looking for koalas in the bush, if you start somewhere where you know there was a koala yesterday, right, then you're not looking at some random bit of the bush. You're looking at somewhere where, if anything, your search is biased in favor of finding more koalas. They're not bears, by the way. It's not a koala bear. So if it is convenient, but it's the largest answerable question we've got, and it's not too convenient in the sense of being biased on those grounds that, if anything, we've biased ourselves in favor of finding more life-permitting universes.
All right, here's a question from CCMNXC, and this is a two-parter. And we just got a super chat, so we'll get to that in a second. So CCMNXC, this is a two-parter. In reviewing your book, A Fortunate Universe, Professor Jan Benetreux Dupin at the University of Pittsburgh at NDPR cites Ehrman and Mosterin in 1999 and McCoy 2015 as people who, here's part two, dispute whether or not fine-tuning is even a problem. So one, are you familiar with these works and their position that fine-tuning is not a problem? And two, if so, where did they go wrong? Seems like a pretty technical question.
Yeah, so I remember reading they're referring to the review of the book that was in the Notre Dame Philosophical Reviews, I think. I think I've read the Ehrman one, but I don't remember specifically what it said. I don't think I've read the other one. I've tried to keep up on fine-tuning in the philosophy literature as well. Sorry, I don't remember exactly what their objection was. I try to collect objections for the fine-tuning argument just for fun. And so I'm probably familiar with what the objection, I just don't remember what those exact paper was. If you want to try and summarize what they said, I'm happy to go for that. But I don't want to guess what they said because then I might be misrepresenting them.
All right, here is the next question. This is a super chat from True Counterphobia. Thank you for your super chat. He says, unpack fine-tuning of John 1 through 14. So just explain what the argument is again. So
suppose it's the case that we wake up tomorrow and let's create a totally fantastic scenario, and the stars overnight have rearranged, and so that everyone waking up when they No, that doesn't work, does it? So suppose when everyone goes out tonight and looks up at the stars, they can see in whatever language that they speak that the stars have rearranged themselves to write out the first 14 verses of John, right? So I look up at 8 o'clock tonight, and there's, in the beginning was the word was with the blah, 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 and off we go, the first 14 verses of John. And, in France, they look up and it's there in French and all of that. Okay, suppose all that's true. It seems like that would be a pretty good argument for God. Not a knockdown argument. I suppose you could believe there were aliens just trying to mess with us, but it seems like that would be pretty good. It might at least, Twitter atheists might stop going, where's the evidence? Thanks. So the form of the argument that if you wanted to formalize that, I mean, intuitively, I think most people would go, all right, God exists, we're done. If you want to formalize it, you might say, okay, look, if naturalism were true, we would not expect that the first 14 verses of John would turn up in the night sky. However, if theism is true, maybe we wouldn't expect it. We certainly wouldn't expect it to the degree that it's a problem for naturalism. There's some level of expectation where that might happen. God might decide to do that. And so in this case, the pattern in the stars is strong evidence for theism over naturalism.
Here's something that I think...
Sorry, let me just finish one thought.
Go for it.
If you wanted to really make the parallel to the fine-tuning argument clear, you could say, all right, I can't get a handle on all the possible naturalistic universes. Of course, there are some in there where the stars line up just to do this. But if I at least think of a subset, say, of all the naturalistic universes where there's a night sky where the stars just appear according to ordinary natural laws, there's an extremely small subset in which they spell out the first 14 verses of John. In that sense, it's a fine-tuned outcome if you're a naturalist, and thus a very unlikely outcome if you're a naturalist, and thus, evidence for theism. So the point is, if you understand why that would be good evidence for God if it existed, you at least understand the logic of the fine-tuning argument. In this case, it's not the first 14 verses of John, it's the fact that our universe permits life. And then just throw your objection at both of those arguments at the same time to see what happens.
All right, so I think this will just be a helpful point in understanding probability theory. We did an interview with Nevin Clemenhaga on probability theory. If you guys want to see more about this, and I don't even know if we talked about this in particular, but I've seen this. It comes up a lot, and I think it kind of hides behind the scenes. It's not something that's made explicit, and so maybe it'd be helpful to just talk about it for a second. So when we're thinking about the fine-tuning argument, the first premise of Robin Collins' argument is that the probability of a life-permitting universe is, given naturalism, is very, very low. That's premise one of his argument. Premise two is it's not the case that the probability of a life-permitting universe given theism is very low. And so all this requires is that the probability of a life-permitting universe given theism is just slightly higher than the probability of a life-permitting universe is on naturalism. So if we're thinking about going back to the data, the awesome theological argument, John 1, 1 through 14, written out in the scars. Let's say that's our data. That is very, very unlikely, and we should be more hyperbolic with that. So it's very, 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 very unlikely, given naturalism, that would happen. That it would just spell out that in the stars. But suppose that it's very, very unlikely that this would happen given theism. That's still going to be very strong evidence for theism over naturalism, even though on theism it's still pretty unlikely.
Yeah.
But I think that we don't understand that. People that are approaching these situations, like, instead of thinking like, okay, on one side of the equation or under one hypothesis, this data is really unlikely, but we don't have evidence for a different hypothesis unless it's very probable on that other hypothesis. But that's not how probability theory works.
Yeah, exactly. So there's a set of objections to the fine-tuning argument, actually by Neil Manson's wrote an interesting paper on this, just whether the atheist can say, the skeptic can say, look, we just have no idea what the probability of a life-emitting universe given theism is, so that's the argument done. Now, if that were true, that is actually correct. That's if you don't have a handle on that probability, it's done. But
I disagree with that. Maybe we can talk about that for a second.
In terms of the formulation of that, if you're relying on a likelihood principle, it can still have intuitive force. But even then, a lot of the quotes that he produces from people who have, so Sober says, Graham Oppin says, it's not clear to me that there is very much one can conclude about the kind of universe that a designer is likely to produce. It's not clear to me that there's much you can say about. That's not enough, right? It's entirely consistent with the awesome theological argument to say, look, it's not clear what verses God would write on the sky if there were, if God decided to write on the sky, or whether he would write on the sky at all. That's fine. All that means is that the probability of God writing on the sky is low. That's all right. It's just not anywhere near as low as the probability of it happened naturalistically. That's all the argument needs.